We will continue our case studies designing a document editor. The strategy pattern which encapsulating an algorithm in an object is the intent of the strategy. So that is we are going to study in the later stage. The key participant in the pattern are strategy object which encapsulate different algorithm and context in which they cooperate. In this diagram, so object structure reflecting compositor directed line breaking. So how the object structure will have a line breaking these things. So here compositor generated glyphs. This is the main parent class. We can say it is a compositor generated glyphs. We'll take it as a composition. So this is called as compositor, the main classes. So how we can break line breaking? So this will be breaking it as first, that is the main column. The entire applications based upon this compositor. So we will break it as entire column. This column again breaking into the another new row. So again row 1, we can call it a row 1. So we had this example in the previous document structure. So this is the row 1, similarly row 2, and similarly row 3, like that, so on. So in this line breaking, so there are a lot of object will be there in the document. So for example, first is the letter characters, capital G, then followed by in that particular row we will have a different columns. So character G will have one column, character G will have another column we are simply kept blank, that is a space. Next, so another column will have an object, that is an image. Similarly, this followed by another line breaking another row. So like that, so we can take it as a different character followed by space or object or a space or followed by any character. So like that, so on, which will be continued. So this is the object structure. We can say that reflecting the compositor directed line breaking. So the next part we are going to discuss embellishing the user interface. So when we consider true embellishment in the Lexi user interface, first we should add a border around the text editing area to demarcate the page of the text. Second thing, add scroll bars that lets user view the different part of the page. So this is the first part we need to take it embellishing the user interface. So to make it easy to add and remove this embellishment, especially in the runtime, we should not use inheritance to add them to the user interface. We are not using the inheritance because whenever we need to modify it, so we achieve the most flexibility if other user interface object if other user interface object don't even know the embellishment are there, so that we will let us add and remove the embellishment without changing the other classes. So that's why we should not use the inheritance. So in this embellishment and the user interface problem of the designing document editor, well, we need to consider first one is transparent enclosure. The transparent enclosure is nothing but from a programming point of view. Whenever we have a programming point in the particular document editor, embellishing the user interface which involves the extending existing code. So that is the nothing but, so we should take it as in a runtime, but equally that is the most complicated form. So whenever explosion of the classes, so that can result from inherited based approaches. So actually we would add the border composition by subclassing, like that is at bordered composition classes. So even we could add the scroll bar interface in the same way to yield the scrollable composition, that is called a scrollable composition. Suppose if we want to both scroll bar and border, we might produce bordered scrollable composition. Together we can call it as. So like that in the extreme, so we would end up with class for every possible combination of embellishment, a solution quickly which becomes unworkable of variety of the embellishment grows. So another thing is here, the object composition always offers a potentially always more workable and flexible extension. So that we need to consider it. So another thing, what does border class look like? So that we need to take it as an issue. Here, actually the fact that border have an appearances suggest they should actually built by the glyphs. We know that border subclass of a glyph, which will be we had in all the previous operations. But there is a more compelling reason for doing this. The client shouldn't care whether the glyphs have the border or not. That client now need to worry about that one. So all this, there are the leads, we can say leads use the concept in this embellishment and user interface. So we can take it as a concept of transparent enclosure. So here which combines the notions, like one is a single child, we can call it as a single component. Another one is composition, that is a compatible interface, that is the child parent. Especially we should have that one in the enclosure, simply delegate all its operations to its component. So whenever we have this one, the enclosure can also augment the component behavior by doing the work of its own before or after delegating a particular operations. So we had seen in the previous videos how delegating, how two objects will be combined to uh, access the one particular object, that is the delegation. The enclosure also, transparent enclosure, which also effectively add state to the particular component. So another part in the embellishment of user interfaces, that is monoglyph. So we can apply actually the concept of a transparent enclosure to all the glyph embellish the other glyphs. To make this concept concrete, so we can call it as a subclass of glyphs called, there is a subclass of all the glyph, that is called as a monoglyph. We can call it as a monoglyph, or you can which serves an abstract class or embellishment glyphs. For example, we had seen in the next videos, we have seen that what is that one, like a border, monoglyph stores a reference to a component and forward all the requests to it. That is called as monoglyph class relationship, will be in the next diagram. So this is the diagrammatical representation, monoglyph class relationship. So the class glyph, the operation is draw operation of window, and that component of that one subclassing monoglyph draw window, border window, that we can draw in a border window of this diagram. Another is scrollable window, that is a draw window for scrollable. Another is draw window or border for the particular windows. So actually a monoglyphs totally transparent to a client by default, because client no need to worry about this, because by default this is a complete transparent, so you can access all the whatever client expected. So this is the some code of segment has given here, how they can access that, or what are the operations of performing the monoglyph class relationship here, how we can implement this. For example, monoglyph glyph implementation, the draw operations, like we are using in the draw operations, draw window, draw editor, whatever it is, void monoglyph. So here the draw operation window w object will be taken, and respective component is draw of w is an object. So here monoglyph subclasses, so actually re-implement at least one of these forwarding operations here. So that will is, one is border draw, another is monoglyph draw. So in the border draw, for instance, first invoke the parent class, so which will always invoke the parent class, that is the, we know that monoglyph class main class. So operation monoglyph draw on the component to the let the component do its part. So this is, that is nothing but draw everything but the border. So and another thing here, the border draw which borders by calling the private operations. We have had seen in the previous diagram, that is the private operations called draw border. So which will be here omitting that word draw border Windows W monoglyph border draw border. So here we can notice that one more thing, draw border, draw scope resolution operator of the draw border here draw, which effectively extend the parent class operations always with to draw the border. So this is the additional facility of this one. Actually this is the context we replacing the parent class operation, which would omit the call the monoglyph scope resolution operator of the draw. No. So here another thing here, scroller. Another thing we need to discuss, a scroller is a monoglyph which draw the component in different locations in the previous diagram. Actually now we will have that all the pieces we need to add the border, how you are going to add a border, how you are going to add a scroller which will be scrolling to the entire application or pages, how we can show that scrolling interface to the Lexis text editing area, particular area we need to see that we can, or we compose that particular existing composition instant to a scrolling or scroller instant to add the scrolling interfaces. We have to compose then a border a particular instance, the resulting object structure, so which we'll see in this diagrammatical representation. So this is the diagrammatical representation of embellished object structure. So we need to take it as embellished object structure. So here a border. So we have embellished the two things here. One is border, another is scroll. And this was there in the previous composition, main composition, compositor main classes. Then followed by the entire main column. So this column will be line break into the row 1. This row will be again line break into the column 1. This column will have a character G, again small g, again column space, then followed by the image object, and so on. So dot dot dot, this is nothing but again we will have the another row 1, row 2. So similar this column. So this is the complete embellished, already embellished object structure. You can say this is the embellished object structure. Another note is that we can reverse the order of the composition. So need not be the same of the order of operation here. So as and when we can reverse the order of the composition, actually by putting the border composition into the scrollable or scroller instances. So that is the in case the border would actually be scrolled along with the text, which may or may not be desirable to the particular task, but we can do it as a reverse order of the composition. So this is the that's why we add a transparent enclosure which make it easy to experiment. So with the different alternatives, whenever we are going to make an alternative changes, so we had that in the previous concept, that transparent enclosure, which always makes easy to the experiment with the alternative or any keep client free or changes in the embellishment code. So another thing, this in the point of this embellished object structure, so how border compose one glyph, not two or more than two. So this is the thing, because composite structure we add all the clear transparent enclosure. So how that one parent object were allowed to have arbitrarily different many objects. So different many children's object. So how putting border around something, we can call it as a singular object creation. And similarly, we could assign the meaning of embellishing more than one object particularly at a time, but that would have the mix many kind of the simple composition with the notation of the particular embellishment. So that we had already discussed in the classes those kind of the composition, which is the better one. So this is the about keeping embellishment independent of other kind of the composition, both simplifies the the embellishment classes and reduce their number, which also keeps from replicating existing composition functionality. So that is the main thing in the embellished object structure. Now in the embellishment object structure, so there is a pattern will be available which are always used, that is called as decorator pattern. The decorator pattern, which we are going to study later, capture the class and object relationship. That's why we had this previous embellishment object structure. So with relationship that support always embellishment by a transparent enclosure. So with all the facilities are available in the decorator pattern. Actually the term embellishment means actually has a broader meaning. So that we have considered here. In the decorator pattern, always embellishment refers to anything which add the responsibilities to a particular object. So we can think of, for example, embellishment in an abstract syntax tree with semantical actions need to be taken. A finite state automata, that is the, we know that with the new transistor, whenever the automata status will be changed. So there we need to have a particular decorator pattern in the network of persistent object with attribute tags. A decorator actually generalized the approach what we used in the lexi to make it more widely applicable. So this is about the supporting of decorator pattern in the embellishment. Next is supporting of multiple look and feel standards. So the next part in the lexi design problem is supporting multiple look and feel standards. So here, achieving the particular portability across the hardware and software problems, whatever the in particular major problems. So in the system design, so we need to take it as a retragating legacy to a new platform, which shouldn't require the major overhaul or the wouldn't be worth retrading. So retargeting, we should make the portion as easy as possible. So here we will assume that so we have to two set of widget glib classes which to implement a particular multiple look and feel standards. So usually we need to take it as the our design goal are to make legacy design is to comfort or which comfort in multiple existing look and feels of different standards. That is our goal. So here a set of abstract classes. The one is the set of abstract classes for each category of widget glyph. For example, suppose that we have taken a different operations of the widget, so we need to take the different category of the subclasses of glyph. So in according to the widget. So whatever the widget in the document editor. For example, an widget will be taken as an example. An abstract class for scroll bar will augment the actually basic glyph interface to add the general scrolling operations. So actually the basic operation of the scroll bar is so we need to scroll the different operations. Actually another is in the scroll bar, that is the button. So button is an abstract class which add the buttons oriented operations, how you can carry out the buttons, click on the particular button. So this is called as a different oriented. So another is a set of concrete subclasses for each abstract subclass that implement different look and feel standards. So for example, again we will take an example of the scroll bar. Scroll bar might have a motif scroll bar that we had in the previous slider, a motif scroll bar and PM scroll bar. So these are the subclasses that implement the motif and PM is the presentation managerial presentation. So that is the presentation manager style scroll bars which respectively. So in this abstracting the object creation, we will come to know that legacy must distinguish between the widget glyph for different look and feel styles. We know that, for example, when legacy need to put a button in the interface, so it must always instantiate a glyph subclasses for the right style of the button. So we had an example, motif button, primary. So the presentation managerial button, Mac button, so etc. So one thing we need to clear that Lexis implementation cannot do this directly. So using constructor call in the C++, that we need to consider it. Another thing, Lexi need to await to determine the look and feel standards that being targeted in order to create a particular or appropriate widget. So in this case, factories and product classes. An example, we need to abstracting the process of object creation. So we can achieve that both abstracting an object creation. An example we will illustrate with meaningfully here, factories and product classes. Normally, so we might create an instance of motif scroll bar glyph with the following C++ code. So this is the segment of the code we have taken, how we can understand a better illustration of this abstracting the process of object creation. So scroll bar start the object we have taken SB equal to new motif scroll bar. Another is scroll bar SB we have taken. So actually this kind of the code we need to avoid if we want to minimize the exist look and feel dependencies. But suppose we initialize the SP as follows: scroll bar star of SP is an object. So GUI factory. So instant to the create scroll bar. So that is the GUI factory is that nothing but graphical user interface factory classes. So all this is possible because the motif factory as a is a subclass of graphical user interface factory. So an abstract of class that defines the general interface of creating widget by using the glyphs. So another thing which includes the operations like a create scroll bar and create button for instantiating different kind of widget glyphs, subclasses of GUI factory which implement these operations to return the glyphs, such as we have used in that one motif scroll bar and PM button, so which implement a particular look and feel. So this is the diagram where we can see that one complete hierarchy. So that is graphical user interface factory classes hierarchy. So we had discussed in that previous slide GUI factory. Whenever we need to avoid that, minimize the exist look and feel dependencies. So we had a scroll bar, a star into SP as an object, GUI factory, and followed by create scroll bar. So that is how we can take it as the GUI factories. So in that diagrammatical representation, so resulting class of hierarchy for graphical user interface factories of object, however the whatever the object will be taken. So we say that here factories can create a product object. So we know that in general, so product that factory produce related to the one another, that is nothing but the, whatever the factories product of creating the object which are related to the another object. In this case the product of all widget for the same look and feel, because the entire widget which are applied by the same factory created object, or you can say the product. So this is the diagrammatical representation, the main GUI factory class. So here create scroll bar, create button, and create menu, and dot 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 means nothing but there are a lot of operation can be taken which and all required. So finally what we need to have, so here always we are looking for supporting multiple look and feel standard. So we need to have that multiple look and feel standard. So here motif factory followed by create all, create button means, and another is PM factory, create scroll bar of this one, create button, create menu. Similarly create Mac factory, create this one. So these are the different operations will be followed, return type of all the subclass of this one GUI factories. So this figure 2.10 which shows that some of the product classes need to make the factories work for widget glyphs. So here the main class glyphs, and so we had taken that subclasses of scroll bar, button, menu. So this menu scroll bar is followed by motif scroll bar. Similarly Mac scroll bar, then followed by the operation is scroll to integer, and pm scroll bar followed by scroll integer. Similarly motif, so this is the press button, because we need to take it as a button, operation is the press. So motif button, mac button, and pm button as all the operation followed by press. Similarly menu will be opened, look and feel. Pop-up menu will be opened, so that is the motif menu. Similarly mac menu and pm menu, so all the operations are pop-up operations. So here this is the what is that one, we need to take it as an abstract product classes and concrete subclasses. So abstract product classes we need to take it a glyph, then followed by scroll bar and button of all the operations, that we need to take it as a different things here. So what we need to do, where does the GUI graphical user factory instance come from? So that we need to answer it here. So this anywhere that convenient. So the variable GUI factory always could be a global. Actually a static member of all well-known classes, or even the local variable if the entire user interface is created within the one class or a one function. So there is even design pattern. So we have a singleton design pattern that is very suitable for these kind of look and feel standards for managing the one kind of the object like this. Another thing is to initialize the GUI factory at a point or in the program or before. So we need to use to create a widget, but after clear the look and feel is desired. So we need to set the desired object is target. So another thing, if the look and feel object here in the diagrammatic representation which compile time. So look and feel is a noun at compile time. So then GUI factory can be initialized with a simple assignment of a new factory which is instance at the beginning of the program. For example, GUI factory in which is followed by that GUI factory equal to new motif factory. So here if the user can specify the particular look and feel with a starting name. So at the startup time, then you need to code it to create a factory which might be the always a GUI factory or the style name look and feel. So that we need to consider. The next exists design problems in a document editor supporting multiple windows. So after that one, look and feel is just one of many portability issues. Another is windowing environment in which Lexis runs. A platform window system creates the illusion of the multiple overlapping windows on a bitmapped display. So it manages the screen space for windows and route input into them for keyboard and the mouse. So here we need to think about encapsulating implementation dependencies. So Windows class interface. So there is a table of this Windows class interface and what and all responsibilities and the different operations. So responsibilities given by this Windows class interfaces. First, Windows management. So we need to consider the responsibility in the two types. One is Windows management, and another is responsibility in the Windows graphics. So operations under Windows management are: one is virtual void, return type is void here. Redraw operations encapsulating the implementation dependencies can be taken as support of or supporting multiple windows. So here can the abstract factory, there is a one more concept here. Abstract factory is factories that product are the actually key participant in the abstract factory. So abstract factory design pattern which are always suitable for supporting multiple window system, which is always supporting. So can we use an abstract factory here, because lot of the problems issues will be coming. So we need to go this address these issues supporting multiple window systems. So in this case, encapsulating implementing dependencies, we need to check it how we are going to address this one. One is the Windows class interface. So that is the operations under different Windows management. Virtual void rise, so rise up the operations in that virtual void lower, and iconify and de-iconify. So we need to take it an icon in the particular in a multiple windows whenever it is required. We can call it as an iconify and de-icon. So whenever it is required and make it as an icon, otherwise de-iconify. So these all are the 1, 2, 3. There are 5 operations under Windows management responsibility of operations. Another is responsibility under this one is Windows class interface is graphics. So under graphics, there are a lot of operations we need to consider. One is void, is again all the void is return type. So draw a line with the following parameters. Virtual again void, draw rectangle. So whenever we need to have the rectangular particular part, and draw polygon. So different types of the polygon can be drawn here, different types of the line can be drawn here, and draw rectangular shape can be drawn here. Another one is void draw text. All the size of the variant or uh, uh, different views of the text, whatever the types of the line of the text can be drawn here. So this is the table. We can take it as the Windows class interfaces. So Windows class interfaces. So we have that is the Windows class displaying the actually a glyph or a glyph structure on the particular display. So actually we don't specify in the Windows system, that is the object worked with, because the we know that doesn't which doesn't come from any particular Windows system. So Windows classes always encapsulate the things Windows tend to do and across the Windows system. And Windows class must span the functionality. So whatever the functionality of Windows from different Windows system. Let us consider there are 2 examples given in the next slides. Okay, so encapsulating implementation dependencies. So we can have the different types of that. One is they provide the operations for drawing the basic always the basic geometric shape, and they can iconify and de-icon. This is the major role in the supporting multiple windows. Whenever we need to have that one, so we can iconify it, and we don't want to that particular operation, so we can take it as an de-iconify. So that is themselves, why it is that one, and they can resize themselves. That is the latest facility, and they can redraw their content as per the demand of the customer or client expect. What the client, for example, when they are iconified or deicon, whenever overlapped with a particular structure or position of their screen spaces exposed. So that we need to take it as. So let us we will continue in the rest of the part in the next video.